Okay, guys, so this is our first section on graphing rational functions. So, what is a rational function? Let's talk about that first. You're going to see the general form of the rational function right here. This is your general form of a rational function. And all that means is a rational function is a type of an equation in which has a fraction. I know we don't like fractions, but really it breaks down to just that. It's not that big of a deal. We can handle it. We know some properties about fractions that's going to help us. So what you're going to do is you're going to follow along with me here. In this section right here, you're going to write your questions. So anything that you come across, you're like, man, that doesn't make sense, or I need some clarification on that. I want you to write that down here in your packet. So let's go through this together. Let's look at the first example. This right here, y equals 1 over x. This is what we call the parent function. So the parent function is just a function in which it's the general shape. It typically looks like this, okay? So you got a curve on the first quadrant and in the third quadrant. So and as you can see, it looks like they touch these x and y axes, but they don't. You see how it looks like the line gets forever close to this dotted pink line, but it doesn't. Okay. In this case, that's what we call an asymptote. An asymptote is a boundary in which it can't touch. So this dotted pink line would be what we call a horizontal asymptote because it's horizontal. So in this case, it would be y equals 0 would be our horizontal asymptote. If you look at it this way, okay, this red dotted line, that would be a vertical asymptote, and it would be x equals 0. So vertical asymptotes have an x equals. A horizontal asymptotes have a y equals, okay? And in this case, it would be 0 and 0. Now, the nice thing about this general form that you've seen up here before, okay, the nice thing about this is that it's in that same form that we've seen all year. We've seen it with vertexes, or I'm sorry, we've seen it with vertex form with quadratics, we've seen it with exponentials, and it holds true. The h value moves it left and right, the k value moves it up and down. So if we're looking at a negative h value, that means we move it to the right 3 units. So instead of being, at the parent function in 0 and 0, now it's here, okay, would be my vertical, and then my horizontal, that's a plus 5, so that means go up 5. So 1, 2, 3, 4, 5. That's going to put us right here. So we have we have our horizontal asymptote, we have our vertical asymptote, and the graph would lie right in here, just like it did before. So pretty easy to do. Our horizontal asymptote in this case would be y equals 5. Our vertical asymptote would be x equals 3, and we're good to go there. Now, the next section has us moving it again. So let's take a look at where this one's moving us. It says a minus 2, which means down 2. So here we go. Here's my down 2. And then a plus 5, which means left 5. Because remember, it's opposite of what you're used to. So 1, 2, 3, 4, 5. That puts me right here. And we'll have that same shape. Okay, that same shape. It'll hold that same shape. Okay? So horizontal asymptote in this case will be y equals negative 2. Vertical asymptote in this case would be x equals negative 5. Okay, and you're good to go. So there's 2 with asymptotes. Let's come down to the next page, well, the next section, and take a look at some different functions. So if we look at this next section right here, oh, I need to move the pen a little bit. All right, there we go. That's a little better. A little easier to see there. Okay. We have a negative sign. You see this negative sign right here? That's going to create a little bit of different thing. We know what the plus 4 is, so handle the plus 4 like you normally would, and then we'll handle the negative sign. So the plus 4 means move it to the left 4. So that would make my asymptote here. And notice there's no k value, so there's no k value, so that's just going to be a horizontal asymptote at the x-axis. Okay? So we know normally it looks like this, right? That's what it normally looks like. But this negative sign is going to change it. That negative sign is going to flip it over the x-axis. So I'm going to back those 2 up. And instead of going in that range, it's actually going to go in this range. So it's going to be upside down. Okay? So there you go. And that'll work. So now that's what the negative does. It goes in the second and fourth quadrant. Okay? All right, so do we even need a graph to define this? You're probably starting to see the pattern here. For a horizontal asymptote, it's going to be this k value. It's going to be y equals that k value. So that's this. And for a vertical asymptote, it's going to be x equals the opposite of that sign. So if it's a -7, it'll be a positive sign. And you can graph it if you don't, if you don't feel like you're confident enough in it, but that's how you do it. Let's take a look at this one over here. So this one has a negative, but does that throw off my asymptotes? It doesn't. My asymptotes are still the same. So in this case, I have my +9, which would mean I have y equals 9. And then in this case, it's just an x by itself. If it's just an x by itself, we know it's x equals 0. It's going to be my asymptote there. The negative really doesn't matter as far as the asymptotes. It does for the graph, but it doesn't for the asymptotes. Let's bring it on down here and look at some different functions. So they can look a little crazy because they can have multiple, you can stack those fractions as much as you want, and the more you stack them, the more complicated they get. So let's take a look at this first one. So HA would be horizontal asymptote, VA, vertical asymptote, x-intercept, and y-intercept. Let's find all this information. So for horizontal asymptote, if we're looking at this, that would be this line, if you look at it, right here, that goes just like that, right through that's -2, okay? So y equals -2 would be my horizontal asymptote. My vertical, you can kind of see it. It looks like, here, let me do it in a different color. It kind of looks like this, where it doesn't touch there, and it also does it here, okay? So that would be a -2 and a +2. So we would have a vertical asymptote at x equals 2 and x equals -2, okay? So those would be your vertical and your two vertical asymptotes. X-intercept. So x-intercept is where it crosses the x-axis. So let's look. If this is 2 here and this is 3, it looks like this point is somewhere in between. Let's call it 2.6 because it's a little more than a half. So we could say an x-intercept would be the point 2.6 comma 0. That would be an x-intercept. And then also over here, it looks like it's in between again, between -2 and -3. So we can call it -2.6 comma 0. That would be two x-intercepts. A y-intercept would be where it crosses the y-axis. Well, in this case, it crosses right here. We could probably call that -3 because we got 1, 2, 3. So that would be 0, -3 for your y-intercept. Not too bad, not too hard to do. So that one will be done. Let's take a look at the other graph, and we'll zip over here. So if you're looking here, your vertical asymptotes are pretty easy to see. They go like this and like this. So it looks like they go through -2 and 3. So x equals -2, x equals 3. Horizontal asymptote. Yeah. All right. So this one's a little bit of a tricky case because if you look at it, it goes along this line. So it crosses here. Yeah, it can cross an asymptote. But as you go out towards infinities, they tend to try to gradually get towards that line. So in this case, this green line would be y equals 1. That would be a horizontal asymptote, okay? So there would be one there. X-intercepts. Let's look at the x-intercepts. We'll go blue for this. Let's see. That would be -1, 2, 3, 4, and 2.5-ish. That looks about right. So we can go 2.50, that would be an x-intercept, and -4, that would be an x-intercept. As far as a y-intercept, let's see what we got here. That would be right about here. So in between 1 and 2, so we could say 1.5. And now, again, I'm just estimating. Oops, we want 0, 1.5. 0, 1.5. And I'm just estimating, but, you get the hang of it. So there we go. That'll be it for this one. Let's take a look at the next little section of things. Finding asymptotes. How do we find the asymptote? So in this case, a vertical asymptote is going to come from anything that makes the denominator 0. So let's just say denominator equals 0. All right, anything that makes the denominator equal 0 would have a vertical asymptote. As far as a horizontal asymptote, a little trickier. If the power on the top is, or I'm sorry, if the power on the bottom is bigger than the top, we're going to have y equals 0. If it's the top is bigger, then we're going to say there's no asymptote or none. And then if the powers are the same, we're going to look at the coefficients. And I'll explain each one of those. Okay, so we're going to look at the coefficients of the highest power. I should write that. Highest power. Okay, let's take a look here. All right, so here's our first case. All right, power on the bottom is bigger. Bottom. So, and what do I mean by that? I mean this 2 is bigger than that 1. Okay, so the 2 is bigger than the 1. Right here, 2, 1. Okay, so if the bottom is bigger, well then in this case we're going to have a horizontal asymptote at y equals 0. That's pretty easy to do. And as far as the vertical asymptote, anything that makes this bottom equation equal to 0. So we need to solve this. How do we solve this? We factor. Yeah, it's been a little while, but that's how we do it. So this will factor down to x minus 8, x plus 4, and that just takes you back to the second quarter again. That doesn't go away. And the two solutions for that would be x equals 8 and x equals negative 4, and those will be our two asymptotes. X equals 8, x equals negative 4. Okay? All right, let's look at this next one. So in this case, the power on the top is bigger. What do I mean by that? I mean the power right here, this 2, is bigger than this 1. So if the 2 is bigger, if the exponent on the top is bigger, we're going to have no horizontal asymptote, so none. And then again, for the vertical, we set this bottom equal to 0. So we have, here we go, we have 4x minus 9 equals 0. So 4x equals 9, and x equals 9/4. So you would have a vertical asymptote at 9/4. Let's take a look at this last case. The last case would be the powers are the same. So what do I mean by the powers are the same? I mean that this 2 and this 2 are the two biggest exponents, so they're the same. So in that case, what we do is we take the coefficients. The coefficient here is a 1, that is a 3. So it's going to be y equals 1/3. That would be your horizontal asymptote. Pretty easy to do. Vertical, also easy. We just set this equal to 0 and solve the bottom. So if you look here, we have a GCF of 3x. So 3x comes out, and you get x plus 7 in there equals 0. So that expression is equal to the denominator on above. So solving that, well, we know that this piece, 3x right here, don't use blue, use black. Here we go. This piece right here is going to be 0. So x equals 0 is an asymptote. And this piece right here is going to be negative 7. So x equals negative 7 is an asymptote. And then there you go. That's how you find the asymptotes by hand. They're not very hard to do. Let's look at the next thing, finding x and y intercepts. We've done this before. This is old news, but last section, let's do this. So how do you find the x-intercept? Well, the x-intercept, you find, let's see, you find x when y equals 0. And you find y when x equals 0. So that's how you find the x-intercept and the y-intercept. So what do I mean by that? Let's look at the first example. If we were looking for the y-intercept, let's do the y-intercept first because it's a little bit easier. What you do is you plug in zeros for all of those x's. So we're going to have 2 times 0 plus 3 divided by 0 squared minus 4 times 0 minus 32. Well, if you look at that, all those zeros are just going to multiply into nothing. So you're going to really just have 3 over negative 32. And there you go. There's your y-intercept. So your y-intercept in this case would be 0 negative 3 over 32, and that would be your y-intercept right here, okay? So that was not too hard to do. Let's look at the x-intercept. The x-intercept is, it takes a little bit of thinking, but if the y is 0, so this is a 0, well, 0 divided by anything is what? 0, right? So if I can make this top section, if I can make this section right here equal to 0, well then this thing divided by whatever would be equal to 0, so I'm good. So what you're going to do is you're going to try to solve that top section. So in doing that, I'm going to have, let's do it in blue. We're going to set this equal to 0 and solve. So we're going to go 2x plus 3 equals 0. So that means 2x is equal to negative 3, and x is equal to negative 3 halves. So that means my x-intercept would be negative 3 halves 0. That would be my x-intercept. So there you go. There's one set. Let's look at the other side. So if we're looking for the y-intercept, again, so y-intercept here, we are going to plug in zeros for all of the y-intercepts. So we're going to have 0 squared plus 5 times 0 minus 36, all divided by 3 times 0 squared plus 21 times 0. And we're going to work that out. If you work that out, oh, this is a weird case. Notice how we have negative 36 over 0. Can you divide by 0? No, you cannot. So in this case, you actually don't have any y-intercepts, which is possible. You can have none. So this is none, okay, because you can't divide by 0. Now the top, again, we'll solve the top, set it equal to 0. Well, we'll notice that this expression right here can factor. So that'll factor down to a, an x plus 9 and an x minus 4. That should get you what you need. So those expressions are equal, which means x equals negative 9 is the solution, and x equals 4 is the solution. So your two x-intercepts would be negative 9, 0. That's 1. And 4 is 0. That would be another one. Okay? So good. Now, let's pull it all together. See if we can pull it all together and answer this question. Okay? So find the asymptotes, intercepts, and then graph. So this is everything together and what I'll expect you to do on the little mastery check. So let's look. Vertical asymptotes. How do we find the vertical asymptotes? Let's think. That means factor the bottom. So in purple, we'll factor this bottom, which makes it x plus 3, x minus 3. Okay? So we're factoring the bottom of that equation, which means I have an x equals negative 3 asymptote, x equals 3 asymptote. So that's done. The horizontal asymptotes, I just look at it and I notice that the powers on the bottom is bigger than it is on the top. So if the power is bigger on the bottom than it is on the top, I know y equals 0 is my horizontal asymptote. That's just from the rules. Okay? So that's easy. Now, x-intercepts. We know we find the x-intercepts by setting the top equal to 0. So we'll do this in blue, I guess. So that would be this equal to 0. So 3x minus 5 equals 0. So 3x equals 5, and x would equal 5/3. Oh, hold on one sec. Okay, we're good. Let's finish this up, and then we'll get back to that phone call. Sorry about that. Okay, so we get 5/3 is your x-intercept, so that's 5/3, 0. And then for the y-intercept, we're going to have, sorry, I lost my train of thought there. For the y-intercepts, we plug in zeros for everybody, and we find out where it crosses. So if we put zeros in for all the x's, we'll have 3 times 0 minus 5 divided by 0 squared minus 9, and that's going to give you 5/9 because the negatives cancel out. So your y-intercept would be 0, 5/9. Okay, so let's plot all that down. So 5/9 is about a half, so we know that's about right here. We know the x-intercepts are at 5/3, which is almost 2, a little less. Okay, we know we have horizontal or vertical asymptotes at 3 and negative 3. And we have a vertical asymptote at 0. So you can kind of see how this is going to start to form. And you can use Desmos to verify. But your function is going to kind of hug this line, come down, come through this red dot, through the blue dot, hug the line. That's 1. And then on this side, it's going to hug the line and come out like that. And then on this side, it's going to hug the line and come out like that. Now, you should probably use a graphing calculator just to verify some of those points, but that's how it's going to work out. All right, well, good luck on the practice problems, and let me know if you have any questions. Oh, lastly, but important, I want you to summarize what you found in your notes here. So summarize what you found today. Okay, write down all the questions you had and summarize the final result, and we'll talk about that as we go. Okay, good luck.